Guys, so we're finally going to be starting on some scheme stuff. Here's the first encounter. There's going to be a lot of code examples, either from Emacs or directly onto the slides. So you may be wondering, how would I follow along with that? Well, if you open up Emacs, you can open up run geyser mode, so meta x run -geyser. Hit through enter and you'll get into Rebel, or the interactive mode. So you can simply type in any code that I tell you to do here. So +11, well, that's going to give me an error. +112, +2 4 6, so stuff like that. That will be fine. But some of the code examples will be dealing with undefined variables, either because I was too lazy to actually keep them from yelling at you, or they may have a significant purpose. For example, if I hit A, yeah, it's going to yell at you because it's a undefined variable. There's no bound on it. And whenever you screw up, there'll be a number that appears in square brackets. This is how deep you are in the debug level. It's asking you, well, how did you screw up? Do you need help? And you can look at, and it'll give you the trace through if you do a (bt), and it tells you where you screwed up at 0. Or you can quit from each of these levels by doing (q). See, that brings me from 2 to 1, and I can do that again, and now I'm on the main level. So that's something kind of neat. But let's see. So A is definitely undefined, and it definitely gives me an error because now we're back down to 1. However, if we do single quote A, that won't give me an error. And the reason for that is, by putting that quote in front of it, you told Scheme that you're treating that as a symbol. Symbols are like the variable x in math. You play around with values using the letters representing values, but a lot of the times you don't need or care about the value itself. You simply need that variable to exist. You need x to exist. That's all the quote does. It says, don't evaluate. You can also do this with lists. So, list of ABC. Notice none of these have values. None of these are defined. So you're going to have an issue here, and we've been brought down to debug level 2. However, if you put a single quote in front of that, it's completely fine. So I hope this makes sense. Really just put in the single quote where you think it needs to be put in if you need to check your answers for something. Otherwise you should be fine. So, got it? Good. Let's talk about atoms. Do you think these are atoms? So, the first one is a series of characters that make up the word atom. Happens to be an atom. Well, what about the next one? It's a single character. Well, that's also an atom. It's just one character by itself. By extension from the first one, will chicken be an atom? Yes, it's a series of characters. It just happens to spell chicken instead of Adam. Well, what about the thing under that? Is 1492 an atom? Yes, actually. Because it's still made up of characters. Finally, what about this weird looking string that looks almost regex-like? This is also an atom, because it's made up of characters. So try to think about what atoms might mean, especially now that I'm going to show you this next concept. What are lists? Are these lists? So, that first example is atom surrounded by two parentheses. We've already said that atom is an atom. So, is that a list? Well, yes. Because it's parentheses surrounding an atom. Well, what about the next thing? It has a quote in front of it, but it's got an atom inside of the two parentheses. Well, that's also a list. It just happens to be a quoted or symbolic list. And as I said before, putting a single quote in front of something makes it a symbol. But it's still a list. Well, what about this next thing? It's got two elements in it. And it's got two elements in it, but it still has parentheses on the outside of both of those. Are those lists? Yes, they're lists. Because it's got two elements and it's surrounded by parentheses, and the parentheses part is what makes up the list. So what about this next part? It looks like it has 3 atoms, but there is parentheses surrounding 2 of these atoms. So is this a list? It's still, well, yes, it's still a list. It just has a sublist inside it. So here's something rather more interesting. The next thing is a list, or is it not a list? The answer is that it is a list. It's just an empty list. So what does that make the next thing? It's still a list, but it's a list of lists. And the internal list just happened to be empty. And that's about it. So I've shown you atoms and I've now shown you lists. And these are the 2 fundamentals in Lisp languages. So let's talk about S expressions. Are these S expressions? The first one is an S expression because all atoms are S expressions. So what about the next one? It's a list. Well, yes, because all lists are also S expressions. So what does it mean in the next one? The next one is also a list because all lists are S expressions, and it just happens to be inside of a larger list, which a list is still an S expression. So the rest of these are fairly easy at this point. So that's a list, that's an S expression because it's a list, and that's just a really complicated looking S expression. So here's your first homework. Define atom, list, and S expressions in English. There's going to be a few more slides of these, so try to be patient. It's really important that you get down these concepts. I didn't go out of my way to make a definition for you because I really need you to figure out what it might be based off of your own intuition and maybe research, especially for S expressions, which I just told you that all atoms are S expressions and all lists are S expressions. So what does that mean? Think about that. So let's continue. Car in CDR. CDR, also known as cutter. What are these? Well, let's consider what a list in Scheme is made out of. If you have an L made up of the list of A, B, C, D, E, then when you do the car of L, you get A out. But when you get the cutter of L, you get the list of B, C, D, E. Do you get it? We can also prove that in Geyser. Let's see. So define L to be A, B, C, D, E. And we get the car of L, you get A. You get the cutter of L, and you get list of B, C, D, E. Define is an important keyword in which that it allows you to make a global definition or a global binding. I'll let you play with that. So let's go through this exercise. So what's car of L when L is any of these? So I don't think car is a very hard topic, so let's go ahead with these. The list of Mario, Luigi, and Toad will have the car of L of Mario. So what about the next one? Mario is now encased inside of a list. So what would the output be? Well, it turns out that it's the list of Mario. Which, you know, it seems to make sense. You still get the first thing out of this. So what about the next one, where your first element is the list of Mario, Luigi? Well, car of L for that list will now be the list of Mario and Luigi. And finally, you have a list of AND, which has the element, the list of Mario, and just the atom Luigi. Well, car of L of this will be that first part. Pretty simple. So let's look at the opposite. The cutter of L, given these lists. So for the first one, since car of L was Mario, then cutter of L will be everything else. So it'll be the list of Luigi, Toad. Well, what about the next one, where Luigi, Toad is inside of a list? So it turns out that cutter L of this is the list of list Luigi, Toad. So what about the next one, where Mario, Luigi are encased in that list? So cutter L will actually grab you the the list of Toad, just Toad, and it'll be the same for the next one. I'm hoping that you're seeing a pattern by now. So I hope that you get it. If not, play around with it in the geyser repo and see what your understanding becomes. And I'm just going to cover in the edge cases of what you might be interested in knowing. What if you got the car of just an atom, say Pikachu, or the cutter of Pikachu? Well, it seems to me that car and cutter get the beginning and end of a list, so that doesn't make much sense for an atom. So they're both undefined. Actually, if you plug this into geyser, it'll confirm this in the way that it'll just make an error. So let me play that for you now. So car of Pikachu, and I'm down one debug, I'm up one debug level, and it's giving me an error. Let's try cutter of Pikachu. Similar result. So that sucks. But, you know, what about an empty list? Because, you know, this stuff is supposed to work on lists. So what happens when it's empty? Well, now you have the problem of there's nothing to split. So this case is also undefined, and I can prove that to you, and it gives a different error, where it's just a simple syntax error. I can get it to work as a symbolic list, but just it still doesn't work. So similarly, right, so I am down to level 6 at this point. Okay, so that's also a bust. You can't get the car and cutter of an atom, and you can't get the car and cutter of a empty list. So what happens if there's only one element? Well, let's think about it. Intuitively, car will probably get the atom apple back out. But what does that leave for cutter? Well, cutter gets everything that's not the first, which is nothing. And that's actually what happens. You get car of L is apple, but cutter, since there's nothing left in that list, will just return an empty list. And I can prove that to you here. Makes sense. And still makes sense. And I'm going to go back up to the main level. Right. So here are some laws. CDR is always pronounced cutter. It's from way back when we were still doing things directly with registers, or everyone had registers in the brain. Car is only defined for non-empty lists, and so is cutter. And the thing about cutter is it always returns another list. There will never be a time, unless it errors, in which it always returns another list. So, if you got the time, copy this in, trace it, see how, see what the value of each of these are. Yeah, so if you need help with either deciphering this or figuring out if you've gotten the correct answer, or if you find out that I've made a humongous mistake, post on Piazza, but I'm pretty sure this should be okay. Right. So, some more homework. Define card cutter in English in the context of a non-empty list. We don't really care that much about the edge case of an atom or an empty list, because it's more important to look at the big picture of what happens, of what card cutter do with just a general list. So let's continue. Cons. Cons is important just because you want to know. Cons is short for concatenate. And I think that's a really important concept you want to know in Lisp. And this will hopefully show you why. So you've got an A and you've got a B, and your cons takes A and B. What is the output? So you've got apple bottom and jeans, and cons apple bottom jeans will get you the list apple bottom jeans. So what about the atom lonely to the empty list? That'll get you the list lonely. But what if you do the list of apple bottom concatenated to the list of jeans boots? Well, what happens is you get the first element as the list of apple bottom, and then the rest of the list in B tacked on to the end. I think you can see the usage, how you might use this for a more dynamic program. So I hope you get it. So let's talk about the edge case. If you have the list of apple and you put it together with the atom bottom, you're going to have a weird issue in which this dot appears. As you notice though, the list of apple will still appear at the front, but suddenly bottom will be after this dot. And it'll be the case for all of these. So, what's the deal? Honestly, don't worry about it. In general, if you're getting lists that have this dot syntax to it, you've probably made a mistake. I recommend looking it up, but it's not necessary for you to know what this is. In which the best way to avoid it is just to follow this law. Cons always takes two arguments. The second argument is always a list, and cons always returns a list. So try these out. Yeah, I had fun writing this one. This was fun. And more importantly, define cons in English. So what's null and what's atom as functions? So atom, we've already asked this question earlier. If you do the atom of A, if you ask the question atom of A, then this first one is true because atom is an atom. The next one is true because A is also an atom. the thing after that is true because chicken is an atom. Next one's true because 1492 is an atom, and that string is an atom. Now, I've noticed, though, that this particular function does not exist in all versions of Guile. Yeah, like, I'll demonstrate this. It doesn't exist. Later on in this course, you can probably define one. It's not that difficult, but it doesn't exist in all versions. I remember that some time ago there was one, though. So, let's go on. So if you ask the question null of A, what is it if A is an empty list? Well, it's true. Meaning, all null lists are empty lists. And we can check that here. Right, true. And false. If you haven't caught on, by the way, what do we call these again? Orthosharps, hash. Hash T is true and hash F is false. So, your law here is that null is only defined for lists. It isn't defined for atoms. I think that... let's check. Yeah, it'll still work depending on the implementation that you use, but according to the official specifications, you shouldn't use this question on atoms. So, here's your homework. Define the question null and the question atom. So, now we're going to work with eq. So, when you ask the question eq of two elements, what is its result? So if A is the atom apple and B is the atom apple, then UX, then eq probably does true. So what if A is an atom and B is the list of atom? Then eq will return false. And if they're both empty lists, it returns true. So I think it's pretty obvious what eq does. It takes two arguments that are non-numeric atoms. It will work for numbers depending on implementation, and it will work on lists depending on the implementation. But if it's not always guaranteed, so you may occasionally end up with a surprising answer. So really, you're only supposed to use eq when there are two non-numeric atoms. Lastly, if you need more practice, go through the code examples and translate them all into English. For example, the car of cutter of car of the list AB and the atom C should be read as the head of the sublist of the head, etc. So that's it for these slides. I hope that you got something out of this. I'll be posting up more slides soon. I'll try to change them up if they're a little too boring or a little too dry. Just let me know. And finally, thank you all for watching. Bye.